So in binomial expansion, it's important you know how to compare coefficients. Okay, compare the coefficient of x squared, x, and even a constant. Alright. So in this case, okay, they want a multiple of 2 expansion. So let's do the expansion separately first, which means 1 plus ax to the power of 4. This guy is equals to 1 to the power of 4 plus 4 choose 1, 1 to the power of 3 ax plus 4 choose 2, 1 to the power of 2 ax squared. Okay, they want up to containing x squared only. So for this guy, because you are going to have x squared inside, you can stop really. Alright, and this is approximate to 1 plus 4ax plus, use your calculator, 4 choose 2, okay, then you will have 6a squared x squared. So this guy is for the 1 plus ax to the power of 4. Same thing, let's do 1 minus 4x to the power of 3. This guy is equals to 1 plus 3 choose 1, okay, 1 square negative 4x plus 3 choose 2, 1 negative 4x bracket square. Okay, so this guy is equals to 1 minus 12x. Okay, how do I get 12? This is 3 times negative 4. Okay, next one, plus, use your calculator, 3 choose 2, you should get 3. So this guy is 3, then this guy is 16, negative 16, 3 times negative 16 equals to negative 48. Sorry, this is positive 16 plus 48 x squared. Okay, plus dot dot dot, plus dot dot dot. Alright, or rather, we should not have the plus dot dot dot, we should have the plus dot dot dot, and these are your. Okay, now, but they do not want these two, they want the multiplication of these two. So this is 1 plus ax to the power of 4 times 1 minus 4x to the power of 3. This is the same as 1 plus 4ax plus 6a squared x squared. Multiply by 1 minus 12x plus 48x squared. Okay, so now we expand. And then you look at how I write. First, I use my 1 to multiply by everybody. Okay, so this will be 1 minus 12x plus 48x squared. Next, I use this, my 4ax to multiply by, to distribute to everybody. Look at how I write. I don't need to, that's not necessary I need to continue writing the line. I can just write this, plus 4ax, okay, because I use this guy multiplied by 1, this guy multiplied by 12, and this guy multiplied by the last one, plus 4ax minus 48ax squared plus 4 times 48, that will be equals to 192ax cubed. But this guy, do we need? We don't need, so we don't need him anymore. Okay, so basically the last one, you have to see for yourself that whenever anything that you multiply, there is more than x squared, you don't need already. So for the last guy, I only need to multiply by the first guy, because that would give me a plus 6a squared x squared. Okay, if I multiply this, I will get x to the power 3, which the question didn't ask for it. The question only wants to ask for x squared. Now I rearrange them all nicely. This will be equals to 1 plus, I take out the x, this will be 4a minus 12. Okay, next, I take out the x squared, this will be 48 minus 48a plus 6a squared. Okay, where do you get them? There they are here for this guy, and then they are here for this guy. Alright. Now, they also tell you that given that the first two terms in the expansion are p plus qx squared, okay, which means that this guy is equals 1 plus 4a minus 12x plus 48 minus 48a plus 6a squared x squared is equals to p plus qx squared. Now something is missing. Alright, you look at the right side. What is missing? There is a, why the right side got no component of x? Because the coefficient of x is actually 0. Okay? So firstly, let's compare the constant. And constant, what are constant? Constants are those numbers that doesn't have x, which means the left hand side is 1, the right side is p. So therefore p equals to 1. Okay? Next, we compare the coefficient of x, which means 4a minus 12 on the right side. What is the coefficient of x? 0. So 4a equals to 12, a equals to 3. And once we got a equals to 3, we put it to the coefficient of x squared. Q is equals to 48 minus 48a. So a is 3. I put 3 inside plus 6 bracket 3 squared. And this, I will get negative 42. Okay, so the important part of this question is, after you do your expansion, when you only want the terms containing the x squared, those that is more than x squared already, you don't need to evaluate it out. Okay, you don't have to evaluate it out. Alright, and then use the comparing of coefficient to get your unknown.